Um, hey everybody, I'm Christine. I'm the instructor today. I just wanted to check and see, are there still people here that haven't finished the setup that I asked you to do beforehand? Could you just like raise your hand? Okay, so one person over there. Do you need help doing that, or can you just? Oh, who didn't do it? Does anyone need help with the setup right now? Yeah, and then like installing the dependencies. Okay, I just want to make sure that people do that right now. So there are a couple people in the room that are also instructors. So back there, Evan, stand up. That's Evan Freeman. He's also going to be helping out today. And then there's Leo right here, who's the host. Um, so if you need help, grab one of these people, and they can help you out. I'm just gonna like give people a couple more minutes to kind of get in and get settled, and then we'll get started. Yeah. Yeah, you just come around, actually. Oh, yeah. Yep, and then you click on that. Yep. Okay. Yeah, I think that's fine. So it just says you're not gonna be able to run code in the notebook. Um, I've kind of treated this notebook thing as pretty much like a static handout. So you don't actually need to be able to run anything, I don't think. To not be able to run code. Click OK. Can you just like scroll down and see? Does it? Okay, so it loads things. Yeah. Okay, cool. but you just can't run things.
I would imagine.
I guess it just means the buttons are not going to do things because it doesn't have a persistent connection.
Okay.
But that's fine.
I just wanted to make sure.
Yeah.
This doesn't need to be functioning.
Yeah, it doesn't need to be interactive. I actually mostly used IPython Notebook because it's like a super simple way to be able to embed code into like a markdown document and have syntax highlighting, and like it's cool that you can like run things and have it just kind of embed it right there. Yeah, did you have a question too?
Yeah, I haven't been able to get that up and running. I was waiting on my man here.
Yeah, well, I can help too.
Okay, great. That'll be great. And again, if you gotta go, you can go forward. I could just catch up. So I'm not worried
Yeah,
about it.
yeah. Well,
I was trying
take a look just right now.
Yeah. So I got up to the point where here I got 2.7. I've got my text editor. I've got
Okay.
all that stuff.
Yep.
So I've got the pip. Where are we now? I downloaded. Here we go.
Okay, you got.
Iron PyCon, and we are on Search 101 Master.
Yep.
Okay, so I got the get pip Python code that I ran that to install it, to install the pip.
Okay.
And then I was just confused as to where this install would occur.
Oh, I see. So have you installed pip already?
I thought I was doing that by creating.
Yeah.
No, not there.
No, because you were actually in the Python command line.
Right.
You just install
Yeah.
it in PowerShell.
Okay.
You can do that through PowerShell.
Yeah.
If you go to the
Okay, I'm gonna let Leo help you. Cool.
pip, how to spell pip, they have a document.
All right, everybody. I know some people are still getting set up, but we're actually going to get started, and people can continue to work on the setup issues as you go along so that everyone doesn't have to sit around waiting for people to get things installed. If you're still working on setup, just grab one of the helpers if you need help, and they'll be happy to do that. I'm just going to like talk over those conversations so we can get moving. Anyway, hi everybody. My name is Christine, and welcome to PyCon. Who is this their first tutorial? First part of PyCon? Cool. Welcome to PyCon. Who took a tutorial this morning? Oh wow, gosh, tutorial fans. Great. So today we're gonna talk about search, and let's see. Briefly, an introduction to me and the other teachers here. My name is Christine Spang. I did my undergrad at MIT. My involvement in the Python community goes back to, gosh, I mean, Python was maybe the first language I actually learned. But in Boston, I was heavily involved in the Boston Python user group. And I actually started this workshop called the Boston Python Workshop with a few people I know. Jessica McKellar is one of them. And that workshop was teaching Python to women. It was a very introductory course. So that's kind of where my Python teaching experience began. And since then, I actually moved to California and started a company that's building the entire product in Python. So I really like Python. And other people here, Eben in the back, was also MIT, and we go way back. We climbed together a lot, and now he works with me. So good times. All right, so our goals for today. So this is a 101 type class, and that means that we're going to start from the very beginning. I'm assuming that you have like a working knowledge of how to program in Python, but no domain knowledge of search. So it seemed like from the people that responded to the little pre-survey that I sent out, that's pretty much where people are at. So there's like a kind of diverse background of experience in Python, but people are pretty much starting on square zero with search, which is what I was going for. So yeah, so I hope to leave you guys today having a basic conceptual understanding of kind of the high level ideas behind how search works. So search is this huge topic. There are people that have spent their entire lifetimes working on like tiny little parts of search. we're not going to go into like tons and tons of details about those kinds of things because you could spend your entire lifetime on them. And for most people, as applications programmers, you don't actually need to know all those nitty-gritty little details. You just need to know like how to build search into your application, and kind of having like a high-level understanding of what's going on will help you build that. So we're going to be using this library called Whoosh, which is a pure Python search library that was written by this guy, Matt Chaput. And it's a great first search API to learn. And one reason I chose it is because it's pure Python, so it's really easy to get set up. And it's totally good enough for a lot of different applications of search. So you'll be able to like take this knowledge and actually use it in your applications. And then I'm going to give you a bunch of pointers to as to like what to do if you want to learn more. So that's kind of the outline of today. And I'm going to run this in very much like a workshop fashion. So we're going to talk about some of the concepts, and then we're going to like set you loose on some tasks. This is very much, it's based on a project. So there's a bunch of code that you downloaded, and you're going to be working on modifying that code to add some features and functionality. Yeah, so let's get started. So why is search important? So I'm going to talk a little bit about the history of kind of search technology or information retrieval for a minute here. So back in the day, so the history of information retrieval goes beyond the history of computers. People have been cataloging information manually for millennia, actually. But an example that you might be more familiar with is like a card catalog from a library. So libraries were a place where information retrieval actually started. People use this thing called the Dewey Decimal System and use that to organize books so they could find them again. But right around the 1950s, people started playing around with using computers for search. And this is because as a society, we have continued to generate more and more information, kind of at like an exponential growth rate. And I say like in 2008, Google was processing 20 petabytes of data per day. So like on that one hard drive there is probably more information than is in an entire library 100 years ago. So when we have all this information, we come up with this problem of like, how do we find what we're looking for again? And that's what's driven the field of information retrieval. It's developing techniques for finding things again based on queries. So we pretty much use search for everything. What's one thing that you use every day that you need to search for? Can someone give me an example? What's that? Okay, so like searching like on a map. Okay, cool. What else? Okay, you search your email. Maybe look up some information that you know is in your email. Cool. Anyone else? Okay, cool. So you might search a log file for a particular thing. And I'm sure that you guys have come today with ideas of things that you want to build, that you want to be able to search. So can someone tell me one thing that you want to be able to search when you're building something? Anyone? Yeah. What's your name? Tom? Okay.
Test results. I want to be able to test them based on criteria, date, time.
Okay, interesting. Okay. Cool. Does anyone else have another example? Yeah. What's your name? Walker. Ah, interesting. Okay. Okay. Cool. What else do people want to search? Thanks, Walker. Yeah, in the back. What's your name? Kyle. Mikhail. Okay, I got it. Yeah. Okay. Okay. Cool. So a database. All right. Those are all really good examples. Right. So we are gonna learn how to like create data structures that allow us to search these kinds of things. So you can think of there are basically a few different concepts that are useful when you're thinking about search. So I'm going to use the information, the language that people use when talking about information retrieval literature. This is like what people in academia who are studying information retrieval use. People often just say search. In like formal study, people call it information retrieval. So I'm going to use some of the terms that people use in that, just so that you guys have the terminology to continue learning more. But most of them are pretty simple, so hopefully don't get too hung up on it, because it's not that complicated at all. All right, so the first thing that you need to know about is documents. So a document is basically the unit of thing that you're wanting to search. So in Mikhail's case, it might be like one entry in the database, and there might be a couple different pieces of data, like different columns. So like there might be like a date, and there might be like a text field, and those are all part of the same document. So if I'm typing in a search query and I want to like find a particular entry in that database, that entry is your document, but it might have different parts. So that's a document, and depending on what you're searching, the document can be different sizes. Like if I'm searching some documentation for like a library, it might be, the entry for a function. Or if I'm like searching a book, it could be a chapter. So that's what you retrieve when you actually enter a search query. So there are basically two major problems that people have to solve when figuring out how to search things quickly. One is, how do we process the information we're trying to search and form a data structure that allows us to find things quickly again? And that's called indexing. So you can think of indexing the same way as you think of like an index in a book. So we're just going to be making basically like a book index for the data that you're going to be searching. So at this point, I'm going to pull up the worksheet. How do I stop this presentation? Oh wait, like this. Okay, so I have this worksheet that you all have as an IPython notebook. And this worksheet actually contains everything I'm saying here and probably a bit more, because it doesn't forget and I wrote it all already. So indexing. All right. So as we say here, a simple case of doing search, you might think that we can just go through an entire document and use like a regular expression to find what you're looking for. And that works in some simple cases. Like someone gave the example of looking for things in log files. And when you're doing that, you probably actually just use a regular expression and search the whole thing. But that comes short when you want to have queries that are really fast. You might notice that if you're like searching through a really long log file, it's pretty slow, and it'll take a few seconds to find all the right matches. So if you want to be really fast and you're searching a lot of data, you can't just search through the entire file. Disks are slow, you can't pull up all the data fast enough, and just like the computational power of doing like all those string comparisons is going to be it's going to take a long time. So we have to create this data structure called an index. So here's where it gets a little hands-on. So I've provided you guys with a small little example of how to create an index in Whoosh. So I'm going to pull that up right now. Okay. Can you guys see that okay on the projector? Yes, no? Sort of. Is the contrast not good enough? AV people, can we turn the light off? Like up here? I could also maybe use a different editor or something like that. Is that easier to read? Yes, no? Oh yeah, it's just the colors that are bad? Okay. Yeah, hang on. Give me a second. This is good practice. I'm giving a talk on Saturday. I need to... Profiles, edit, colors. Wait on black and white. Yeah, and then I think I also need to... Hang on. I know this is terrible. I'm just gonna change this. Right, there we go. Okay. Can you read that? Okay, cool. That's good to know. Right. So this is a tiny little example of how to create an index in Whoosh. So one of the great things about Whoosh is it's really simple. So you can see here that we're using the Whoosh library, and all we have to do to create an index is to define the schema. So there's a few different things here. So the schema is just imported from this module, whoosh.fields. And then you're basically just defining what kinds of data you're going to be indexing. And in this case, all we have is like a document ID, which is unique. And the only reason I have this in the example schema is in order to be able to like update an existing member of the document set if it changes, because you need some like unique element in order to be able to find it again. And then we have this one text field here called content. And then so I have this example of docs that are just strings. And then we create the index down here. This is a little annoying because it's wrapping, so I'm going to make it a little smaller. Hopefully that's still readable. Okay. And then in order to be able to create the index, we just call these functions in Whoosh and tell it to create the index. And then we use this, we get this handle on this object called index writer. And then we use that to add the documents. And at the end, we have to commit to tell Whoosh that we're done. So that's all you have to do to make an index in Whoosh. This is obviously a tiny little example, and your data will probably be more complicated than that. Yes, question, Walker.
Do you want to like come up with some reasonable batch size, and if you're indexing a million fraction of a million things?
Probably not. Just in that, like, if that process is interrupted, you're gonna have to do it all over again. So I don't really know what like a reasonable batch size is for committing. I'd probably use like, I don't know, 50 or 100 elements. Gosh. So back to the handout. We run this little example and that creates an index. So then I've walked through here what files this actually creates on your disk. So if you just have the command line, you can actually follow along. I've actually used this because this is an IPython notebook. I just run this command on the command line from the notebook, which is pretty cool. And it shows me the files that it creates. So Whoosh for this tiny little index, it creates 3 files. One is this one main write lock, and it's just what it sounds like. It's a file that Whoosh uses file locking on to make sure that only one process is writing to the index at the same time. Yeah. Uh-huh. I am not sure what happens in that case. Either there's a bug in Whoosh or it does something different on NFS. But I don't know the answer to that off the top of my head. And then it creates these 2 other files, which are the main things. And you can see that the file program says it's just data, so it's probably just a bunch of binary. Alright, so let's talk about these files a little bit. So this file, main1.toc, is what Whoosh calls the table of contents file. And what's in the table of contents is some versioning information so that Whoosh can change how it deals with the file format and still be backwards compatible. And then it also contains basically a pickle of the schema that we defined before, so that Whoosh can tell what information is in the index. And then it also has a list of what it calls segments. So a segment is the actual index that we're creating. You could write an index as a single file, but that makes it more complicated to update later. So the reason that it's divided up into segments, you only have one segment here because it's such a small index. But the reason that Whoosh divides it up into segments is because of disk access and having to insert things into various. If you like replace documents, having them in segments allows you to do that better with better disk access. All right. Okay, so you've seen like the files that are actually created, but we haven't actually talked about the data structure at all. So we're actually gonna take a look at what's in the index right now. So you can follow along with these commands actually if you just bring up a Python prompt of any kind. So even if you're not running IPython here, you don't need IPython to run this. But you can use this opendir function from Whoosh's API and use that to open your index. And you can see here that there's this method docCount, which allows you to see how many documents are in the index. And then we can get this this object, which is called a index reader, by calling the reader method on index. And the reader is what we can use to actually read information from the index. So I gave you guys a little bit of code right here that will actually go through all the things that are in the index and print them. It seems like people are doing a bunch of typing, so I'll give you all a sec. So I'm going to skip down here to where it's printing out the contents of the index. So I'm going to highlight it right here. It's pretty much all this stuff. right here. So this listing of stuff. You can see that it pretty much prints the field name, and then there's a word, and then there's a bunch of numbers. So this is everything that Whoosh is keeping track of after it processes all the documents that we gave it. So it seems like it's doing a few things. One is that when it has a field that's full of text, it's breaking that up into words. And then, as I noted above, these numbers are one, a document number, two, a weight, and then we have to do a little extra. I actually talked to Matt Chepwood about this. He's kind of embarrassed of this API. He's like, it's going to be better next time. But it stores some other numbers as actually in a binary form. And those are the frequency of the word and the positions in the file. So it's storing this extra information in order to allow you to do some extra things later, such as to highlight words that match your search query. Yeah, so that's pretty much all the information that's in the index. It doesn't really matter what way that Whoosh in particular is storing that. Actually, at the very end of this worksheet, I give you guys a link to a friend of mine, this guy Cragen, who wrote this very minimal search indexer for the next edition of the architecture of open source applications in like 500 lines of Python, which implements an indexer and a querier. So if you really want to know the nitty gritty of how to like do a basic index, that's a great reference to look at because it's really simple. All right, so let's talk about this a little more and relate it to the language that is used in the field of information retrieval. So every element here is called a posting. So this thing right here, it's like content over 0, 1.0, 1. So a posting is basically every entry in the index. And in the case of indexing plain text, it usually ends up being a word, and then whatever other information your search library is keeping about that word. Another term you'll want to know is called a posting list, which is basically just the entire index, or like a subset of the index. It's just a set of postings. So a posting is just an entry in the index, pretty much. And another thing you want to know is in the language of information retrieval, we call this data structure an inverted index. So you might be curious as to why it's called an inverted index and not just an index. And this is just based on, I guess, convention. In that information retrieval, people consider like a forward index to be a mapping from documents to words. And so if you have a mapping from words to documents, that's inverted. So that's what an inverted index means. It's really just an index with a particular directionality to the data that's being mapped. I honestly think I get annoyed that it sounds like something that's like, oh, what's that? It's a special kind of index, but it's really just a backwards index, but it's only backwards if you think something else is forwards. So, actually quite simple. All right. So, at this point, you pretty much have everything you need to know about the basics of an index. And so at this point, I want to encourage you to do a couple things. I'm going to let you guys go and play around for a little bit. One is you can take a look at the API for accessing information from the index here. You probably just want to copy paste it from your worksheet. And two, I've made a bunch of example tasks that you guys can work on that'll help you get a better understanding of what's going on here. So there's a lot of different levels of expertise and experience here. So I want to give people a chance to dive into things at your own pace. So the intention here is not for everyone to like complete every single task. It's to give you things to work on that'll help solidify your understanding. So I want to like set you guys free here, and if you want to talk to someone about something we've talked about, or you have a question, just raise your hand and we'll come around. And what time is it right now? It is 1:53. So I think the break is at 3. Okay, there's like an official break. I think it's at 3. I think we wanna reconvene a bit before that. So let's say we reconvene at 2:30, and we can talk about some like solutions that people came up for the tasks, and also like answer any bigger questions that people have. All right, I've at it. Does anyone have any like major questions right now that you want to ask? Pretty good. Okay, I'm not seeing any hands. So we yeah. Yeah. So we just did that like an hour ago as a backup. So right. Is that Yeah, that's on the web somewhere. I've been meaning to like do that. Yeah. Um .ipython.org or something like that. Yeah. I didn't want to do that right away because like the worksheet was in flux, so yeah. I definitely want to look into that at some point. I'm gonna publish all the material. I mean, I already have published all the materials, but I want to make this available to other people. So. Oh, okay. Into NB Viewer. Let me do that right now. So like the raw from GitHub. Yeah. Okay. Oh, I'm gonna do it. This is fun. All right. I just discovered this IPython thing. It's pretty sweet. Okay, so we want this one. And then how do I get raw? Okay, here we go. Go. Oh, okay. And then, gosh, that's quite a link. Maybe I can like stick that into Bitly or something. Okay. Um. Okay, I'm gonna put this in here. And then make this big. Okay, that's the link. Does that work for people? I'm really sold on this IPython thing. The notebook is pretty sweet. Okay, unless someone yells at me and says it's not working, I'm gonna assume it's working. Sweet. Okay. Can you turn off my mic for a while? Hi, what's your name?
Ding-dong.
Zingdong.
Yes.
Nice to meet you.
How to get it to your notebook? Like I came in late.
Oh, yeah, yeah. Okay. So you want to do? Did you download the repository yet?
No.
Okay. So it's github.com
GitHub.com.
// Spang, SPANG. Yeah, just go to there, and then go to repositories, and then search 101. Yeah, there you go.
Okay, I see. So it's all the slides.
That's the slides, but that's not the notebook.
Okay.
So actually, so you're gonna need to download this code. You might actually. I have a USB stick with a copy of this on it. It'll be a lot faster for you to grab it from that than from this. I'll be right back. Ah, here we go. Gosh, it's in my pocket the whole time. That's ridiculous. Yeah, you got it? Yeah, could you copy that whole thing to your computer?
Notebook and now the material you're showing like
Yeah. So if you pull up this, you should be able to like grab the handout. Like that's what you want. Yeah.
Okay, I can use it.
Yeah. Do you have the? If you want to be able to run the code, you're gonna have to install the dependencies.
Okay.
So
This is a library we're using here.
yeah, if you look at this again, scroll up. See, there's some instructions.
So this is Boston.
Yeah, but if you have experience installing, have you installed Python packages before?
PyCon package, yes, but that's a pure like a Python, not like the other third-party library built on.
Okay. Yeah, so you might want to just install Whoosh,
Okay.
and maybe there's a list of requirements. It's in here. So if you've used pip, you can install the contents of that.
Okay. So these are the dependency library we are using.
Yeah.
Okay.
So you're gonna want to install the dependencies, and then you can use the worksheet.
Okay.
Did you miss how much of the introduction did you miss?
I think they just started with the around the 35, 15 minutes. I think.
35, 50 minutes.
Yeah.
Oh, okay. Yeah. So you missed a bunch of the beginning, but the good thing is that I've written up pretty much everything I said in the worksheet.
Okay.
So if you have like particular questions, you might want to start by just reading through the indexing section, and then just like grab us.
Okay.
There's me, and there's also Eben over there, who can answer questions.
Okay.
Cool. Yeah. Oh, right. Yeah. I want to leave you with my house keys. All right, cool. Oh, did my computer go to sleep? Okay. Yeah, yeah.
I'm not familiar with virtual env.
Okay.
So I have it written here where I started the IPython notebook. If I want to start again this virtual env in here, do I have to do both these lines or just this one?
Just the source.
Okay.
So this is just to set up the virtual env.
Mm-hmm.
You only have to do that once.
Okay.
And then every time you want to run the virtual env, you just do source bin/activate. Yeah, so virtual env just makes it so you can install the dependencies without putting them on your whole computer, which is nice if you have like specific versions that you require of particular libraries for different things. Yeah, so it gives you like a localized install for this particular project. Yeah, that's all you got. Sweet. Hey everybody, how's it going? Any questions? Okay, but it's working for you? Yeah. Okay, cool. Just wanted to check in. How's everything going?
Pretty good. I'm just doing the first task. Like adding like a new something new to the schema. So maybe like an author.
Yeah.
Like an author.
Uh-huh.
I'll just change the loop to update the document.
Cool.
To have it.
Yeah, it sounds like you got a handle on things. Cool. Have at it. Hello. How's it going? Oh, yeah? Where do you think you might start?
Well, I've copied part of the previous example, and I'm just
Yeah.
wondering what type of new identifier I'm going to put inside just this simple document. And I'm just not exactly sure what each of these items mean inside in terms of schema, so I was looking up
Oh, yeah.
things that are already available.
Right.
And
Yeah, so a lot of this,
how
like,
this can apply to the example that we have.
yeah, right,
Not quite there.
So because, like, the examples in this particular example are just, it's just a bunch of text, I wouldn't worry too much about making something that, like, is coherent and makes sense. You just, like, pick some sort of data type, like, add a date to it or something.
Oh, okay.
Um,
Yeah, sure. I
the
can
point
do
is
that.
more to, like, play around with having different fields,
Yep.
and different types of data than to, like,
Okay. That's fine.
have, like, this is, you know, a book page or something.
Yeah, sure. I
Yeah.
just didn't know that we needed to modify the actual
Oh,
template
yeah,
example.
right,
Because I was like, well, it's just text. I don't know what
yeah,
else I can do.
right, yep.
Making it a bit complicated than I expected.
Oh, yeah.
Okay,
Well,
no
I think
worries.
you're on the right track now, so.
I'll get to it.
Cool. How's it going over here?
Just finished zoning.
Okay.
So I haven't started
Yep.
these. There was something you mentioned about the indices. I was wanting to ask.
Okay.
The example points to words. If I wanted to do something where instead of pointing it to words, I wanted to do something like concepts. Like, what are the key
Oh,
knowledge
interesting.
that I would need to apply?
Ah,
For example,
concepts.
like,
Okay, so you want to have, like, a custom tokenizer that
well,
doesn't.
do I don't
Yeah.
know. The question, what I
Gosh.
have in mind is, let's say I have thousands of documents, right?
Yeah.
Many things in these documents that are. So my company says every time we go into an agreement with someone, we want to use the following clauses.
Okay.
We don't want to deviate too much from these.
Okay.
What happens if I do find, let's call these are standard clauses.
So it would be like a phrase?
And I do apply phrases.
A phrase. Okay.
That would be somehow tagged, which would say this looks like a standard clause, or this looks like it's not very standard. And then could I
Okay.
search instead, say, instead of typing a text, because I don't know what I'll be looking for, could I type something like find me non-standard terms in the collection of documents,
Non-standard terms.
or something that's not.
Yeah,
seems
so this
the
is like a
opposite,
whole
right?
nother layer on top. Yeah.
But these concepts, right, of indices can be built not only to exact words, but also perhaps
Yeah,
to anything that I tag as A or B. Or C.
Yeah, I mean, I think you could actually build something like what you're talking about, even using the standard way of indexing. I mean, you could also, like, build a custom way of splitting things up for the index, but I'm not sure that's actually necessary. It seems like the application level logic could deal with what you want. In that, when we talk about querying later, we'll see that you can combine words, and you can actually, like, search for phrases. So if you have, like, a document set, you can, like, find the documents that have that phrase. You can also find documents that don't have that phrase. It depends on, like, what you mean by, like, non-standard. Like, how do you determine like which things are supposed to be in the document?
Yeah, it gets to the grammar.
Yeah,
How things
right.
are spelled out. For example, if we say, want to share our internal documents with a client, whoever we're working with, but if we find something in the document that says we commit to sharing these internal documents with the client, then I would say that's not really standard, right? That'd be like
Oh,
an
yeah.
exception. So these are some ideas
Yeah,
I've been
right.
thinking about, but it's been very hard to put them into practice.
Yeah, so you kind of want to have, like, gosh, it's interesting with, like, legal documents in that, like, all the words in a legal document are important, right? So how do you make that a smaller set of things that you can then kind of structurally?
The problem is that the people I support, right, they're auditors.
Yeah.
What they'll do now, they'll say, well, these are big contracts in terms of money. So they don't want to spend a lot of time on a contract that may not be as valuable.
Oh,
But
yeah.
there may be things that may not be right there. But even then, when they do their samples,
Mhm.
they'll be looking at these manually. They may have some sort of search to them.
Yeah.
It's the person's knowledge that when they read the document, they'll say, well, this doesn't look right to me.
Yeah. Right.
It's a bit of a
Human pattern matching.
yeah.
Yeah. I mean, it seems like it might be more like some sort of like natural language problem than like strictly search. And then like how do you like form a model of like what's like not right
Yeah.
and tell a computer that.
That would still require pieces, right? Years of search,
Yeah.
NLP, and perhaps some machine learning thrown in.
Yeah. There's definitely a bigger system here. So it'll probably help you to like know about kind of the basics of how search is done.
Oh yeah, definitely.
But I think it's probably one piece of your
one of many.
of your mission.
Yeah. We'll see.
Cool. That sounds cool though.
Well, yeah, I gotta put something in place so that I can convince those I work for that. Yeah.
Yeah, that you should work on this problem.
Yeah.
Cool.
Right.
All right. I'll let you get started on the
Okay. Yeah.
the stuff.
But if you have any pointers to maybe techniques or tools or technologies I
Yeah.
should look into,
Yeah, you should look into more like NLP stuff. I don't really know a lot about the field, so the internet can help.
Yeah, definitely.
There are probably some NLP. Are you going to like the conference itself?
Yeah, Friday through Sunday.
Okay.
Yeah. So I'll be looking for it.
I'm sure you can find some people that work on this kind of stuff.
I was interested in there's this company around here, Lex Machina, I think. They do some legal document analysis, I think.
Yeah.
Pick their brain, see if they're willing to share anything.
Yeah. Sounds good. Cool. Good luck. Yeah. Let's do it.
0MQ looks like is failing when we try to do the install.
Error code 1.
I set up.
Oh, I see. Yeah. Oh, right. Gosh. Is this... Okay, so this is Ubuntu. Yeah, so it's failing because you don't have the C headers for ZMQ. So you can you... Have you installed things with apt before? Okay. I'm gonna tell you some commands to run.
Oh, okay.
Yeah. Can you type apt apt?
And as a super user, do I need to install?
Yeah.
Apt
Well,
install or something?
finding the package name.
Okay.
Though, I might be able to just guess what it's called. Yeah, sure. Sudo.
Yeah, so I have
And
that does
trackpad is
alias of
annoying.
sudo apt-get install.
Oh, okay. Yeah,
Okay.
cool. lib zmq dash
Dash cache or just cache?
no, dash, like
sorry.
the dash character. Yeah. Dev dev. See if that works.
Okay.
Come on, you can do it. Updating.
By the way, I really like how you did the packaging on the GitHub repo, the notebook.
Oh yeah.
Contain everything.
Cool. Have you taken other tutorials here?
Yeah.
Yeah. What have they done?
This is the first one that's as complete in terms of the.
Oh, okay. Just like getting everything from the same
I think
place.
that's pretty awesome.
Cool. Yeah.
I would have had this set up, except I just switched to this tutorial today. So.
Oh, okay. Yeah, running
okay.
the workshop that I used to run in Boston gave me a bit of experience with trying to make things easy.
Let's see if that
Yeah.
cleared up our problem.
So see, now it's doing a bunch of compiling. I really
Yeah, I think that's
was hoping not to have any project dependencies that that involved a compiler, but it's just IPython. So it seems like
Thank you.
if I like am more clear about having the static version with the viewer, then people
I
won't
think,
necessarily
just-
need to have IPython.
Just having an environment that's
Yeah.
packaged together is really great.
Right.
It's
Cool.
wonderful.
I'm glad you like it. I just learned IPython notebook for this. That was fun.
I'm in the process of learning, and
Yeah, it's cool.
That's the
It
main
was
thing
just
I
so
wanna
much
get
fun
out
fun
this
to
week is
to
we
write
do
that
it.
worksheet.
I'm
Yeah.
still struggling with just basics,
Yeah.
but I could see the potential. It's
Yeah.
huge.
Cool. Well, if you have any questions, let me know. Yeah.
Oh, actually, right now are we supposed to just be doing the part about the index, huh? Like, are we supposed to go on to the querying part?
Oh, feel free. I mean, we're gonna talk about querying in a bit, but if you're just like rolling through things,
Well,
that's no problem.
It's just like, without querying my index, I'm not sure if I'm really indexing stuff correctly. I mean,
Oh
it's like,
yeah. That's a good point.
I don't know, I added a new field,
Mhm.
but then I'm not sure if it should, like, it has like a listing in the index for every entry I have. Like, I mean,
Okay. Yeah.
which I'm not sure if it, like, if that's correct, because, like, for example, the way it indexes keywords is that it, oh, actually, never mind, it has separate entries for them, in that it has,
Depending on the field.
okay, because I thought it,
Yeah.
it bunches, what was it called, postings,
Yeah.
in, at least within this print function. Anyway, I'm not sure if the index I created is correct, because it has a separate entry, separate posting for every.
Yeah. I mean, I suspect it is right.
Okay.
But feel free to like do whatever you want to like verify that. It definitely creates different entries for different fields. And that's because when you query, you often query on a specific field. So you might want to limit to only searching for the author. Or you might want to just be searching the full text. So you have to have it annotated against both. Yeah. But I think you probably have it right here.
Okay. Yeah, I guess that.
But that's a good feedback for my next iterations. Cool. Oh, how is this side of the room doing? Any questions? Get everything set up all right?
So I'm kind of just like running through the code.
Yeah. Okay. Cool. If you're happy, I'm happy.
Yeah.
Just want to make sure.
I'm not even able to like do simple things. I kind of just want to like. So I've run this code to just kind of see what's in that index. So I'm just like trying to follow. Let's see, I'm just going from right here. Whoosh. Then let's go import Whoosh.
Wow. That's amazing.
I'm just like can't even touch this computer.
Okay, so you're running on a Mac.
So I just like
That's so
leave it.
bizarre.
I'm just gonna leave it alone.
I mean, we should try to figure out what's going on here so that you can work on things. Okay. Can you... That's so interesting. I'm just like mind blown. Okay. And this is like the Python that came with your Mac?
Yeah.
Okay.
I mean, it's just like version 2.7 whatever.
Yeah.
It's not probably. Just type Python and you can kind of see the.
Right.
It's pretty funny. Or actually,
Yeah.
Python I've attached. I've downloaded as well.
Oh, interesting. Are you running the one from your virtual env? Because it like copies it in.
Yeah, I actually don't know.
Okay.
I don't know anything about virtual.
Oh, okay. Well, let's figure it out. Can you exit this shell? And then type ls bin. Yeah. So can you do like ./bin/python? Python. Yeah. I just want to make sure that we're running the one from the virtual env. And then can you try that import again? Okay. That's amazing. My mind's still pretty much blown. Do you usually install things globally?
Yeah.
Okay, try that.
Like all the things I was supposed to download globally, or what do you mean?
Yeah, just like install so type deactivate. And then just do the pip install. You've used pip, yeah?
Yeah.
Okay.
Actually, it wasn't really, I'm gonna use
pip
sudo first.
So pip install -r requirements.txt.
Actually, I did do this globally.
Oh, you did?
Yeah, and then
okay.
the reason we're in a virtual shell is for some reason I had to, when going, this wasn't working. So then he was just kind of playing around and had to go.
Oh, I see.
Shell. But this
Interesting.
This is all globally installed.
Okay, so everything is installed globally.
It should be, yeah.
Can you try the import, like not in the virtual env?
Sure.
I'm just curious whether it works outside of it. Okay, so maybe it's not installed.
Okay,
yeah.
let me just do all that.
Yeah. So just do the pip install. -r. Okay, please Whoosh. Already satisfied.
I guess Whoosh.
That's super weird. Can you do like import sys? SYS? It's like sprints or like sys.path or something. I want to see what your search path is. I don't remember what it's called. I like Google I like print my Python search path, Python module search path. Okay. Modules. Oh yeah, let's look at this. Yeah, weird. What is this supposed to be sys.path? I was so confused. Nope, this is just totally broken. Huh, I'm a little confused. Your Python seems to be quite confused about something. Like what you might want to do at some point in the future is, I think on Macs, like people recommend using the Python from Xcode.
Okay.
So you might want to like install that and like just kind of start fresh. I'm not really sure what to recommend right now.
I can kind of just read along.
Okay, if like you're okay with that,
Sure. I mean, it's not really an alternative, but my computer's kind of not.
I'm not like sure what the right thing. I'm not like super familiar with Macs.
Yeah.
It just seems like your Python is broken.
Yeah.
And I'm not sure why.
Sure. Okay. Thank you.
Cool. Or maybe if someone else knows about Max, they can help you, such as this kind fellow.
Such as the guy with the Mac over here.
Hey Walker, how are you doing?
I've got the stemming working.
Yeah.
And I got the accent stripped out. And so these are the changes I made to your code to make that happen.
Okay.
And all that seems good. But then when I try to actually get a result out, or like it tells me like I've got 2 results. But yeah, I want to see my 2 results.
Okay. Mhm.
I mean, is it, so I just had to like plug in an analyzer based on those 2 things.
Yeah. Okay. That looks good. And then show me what you were.
All right. So, lo and behold, now you see my postings don't have, any stems or accents. Well, hooray for me. But this is an unsatisfying result.
Right.
Yes, there are 2 hits for that query, but I want to see them. And then it shows me, oh, well, in your index numbers are 1 and 4, but I want to see them. I want to see them now.
Yeah.
And then I can't figure out in the API how to actually pull anything about the documents back out.
Yeah, so one thing, I think what you need to do here, so searcher is us. Okay, so I think you need to like iterate through this result. You can probably reference later in the querying code. Like, one thing that someone else pointed out is that it's quite difficult to I think so.
Okay. So.
Yeah, so that will give you a hit. And then I think.
They gave me the right number of hits.
Yep. I think what's the problem here is that in this particular simple schema, we haven't been saving the
stored. It's not stored.
The content. So yeah, if you try changing it to being like store equals true.
Is it what, like that?
I think so. Equals true. Yeah, I think then it'll print it. And then just like rerun this one. There you go. Okay.
So it actually was fetching me the results.
Yeah.
And the results
Okay. Yeah. I'm gonna make myself a note for this to make it clearer.
Okay.
That's a very good point.
Yeah. So now great. It's Christmas.
Yeah.
I've got my present, and there's
Sweet.
a transformer inside.
Nice.
Thank you.
Good work. I'm gonna make myself that note. Hang on. I was just making myself a note. That's someone gave me some good feedback.
So when you change the schema, is it best like to recreate the index and just kind of blow away what was there?
Yeah.
So that was kind of doing a simple example.
Right.
But I imagine that I saw something about like adding fields and stuff like that. But
Yeah, so you can, like, the reason that you want to keep a unique ID on every document is that so you can update them later.
okay.
So it's possible to update existing documents in the index. And definitely if you have like a really big index, you're not going to be regenerating the whole thing every time. If a particular document changes, you just use the unique ID to update the existing one.
Okay.
In this particular small example, I was like blowing away the index the whole time just to make sure everyone kind of got the right thing, even if they were changing it,
But yeah, and then just
to make it simpler. Yeah.
you just run the
But
script.
definitely in a real world example, in something big, you wouldn't do that.
Okay. You just execute
Yeah.
the specific things to create your new schema.
Right.
Or
It's kind of like
how
a.
you want to modify the index.
Yep.
And then from that point on, then you would just use the updated schema.
Yeah. So you'll update the index, and the Whoosh code will do the right thing if it already exists. Yeah. Yep. We're gonna look at a bigger example next, which is more complicated. It doesn't. Instead of blowing it away every time, it just updates. So you'll see an example of that. Cool. How's it going over here?
Very behind because I cannot run the virtual environment.
Oh yeah.
He has a canopy installation that they
Mhm.
use like VM, which is like a custom made backboard or
Okay.
virtual environment.
Can you just install the dependencies without virtual end?
Yeah, we have been trying. I'm trying to configure both.
Oh, okay. Yeah.
But-
It sounds like a mess.
Yeah, multitasking is not actually for me. So you should use this PowerShell.
I didn't even see it.
Yeah. So basically,
Yeah. I'm glad you know how to deal with the Windows stuff.
I have been through this pain
Yeah.
a few times.
Like just like that.
Yes.
Okay.
So, but instead of the Python 33,
Right.
Well, that sounds frustrating.
Yeah, so I have also
What
the
what's,
Ubuntu
what state are you at right now?
virtual machine and it's having the same problem.
it basically
The problem is that
is giving you Oh, so you're pretty
no,
far.
I did that before. This is I'm having problem with this one.
Oh, yeah.
CMQ. That's
Right,
the one that
right.
gave me a problem.
So this is on the Ubuntu, right?
No, this is in the Mac.
This on
On the Mac.
I
But in
think
the Ubuntu, I'm having all
did
other
you
set of
install
problems.
the GCC there?
Yes, it
Yeah.
says it's the latest version. So
Yeah, but I don't know. I have this problem also in my computer. I think it's related to the compilator.
Yeah, so the problem here is that he doesn't have the headers for ZMQ. And I think on a Mac, you probably have to like use like Homebrew or something to install
Homebrew.
those.
Oh yeah.
Yeah.
I hate Brew.
This is annoying because I kind of added the IPython dependency like only like a week ago, and I wanted nothing to depend on a compiler. But if you want IPython, then
no, I use IPython. I don't know what's going
yeah.
on.
So
But it's in Ubuntu. I'm having
No, yeah.
what's the problem you have in Ubuntu?
I don't even remember now what it is.
But
Let's
you
just
know,
run it.
you didn't.
Let's see.
You did something wrong. You have.
Oh no. I got you.
No, you're in there.
I was.
Okay.
Value was
It's very similar. To
Is he
Yeah, the first
very
thing
weird.
is I think you should
Yeah,
install
can you-
a specific version of CMQ. I'm not sure if.
No. Okay, so do apt-get install.
Did it work?
This is just because you don't have the development headers, but we can fix this.
Okay.
So just do sudo,
So try this.
sudo
Not working.
apt-get install. lib, L-I-B, ZMQ,
Okay, right now it's on.
dash,
I'm sorry. Dash.
yeah, dash dev, D-E-V. Okay.
Let's see.
And you gotta get your password.
Oh.
Okay.
Virtual?
Yes. I'm sorry, my English is not that
No,
good.
that's fine.
So this is,
Yeah, no, with the M.
yeah, so then do the pip install again.
Yes, that's.
See, it's working this time. Oh, what? Oh, this is like you need to run it with sudo. This, I don't know what's going on.
It's just a mess. It's just driving me crazy.
Yeah.
Doesn't it seem like it's a nuclear reactor that is failing somewhere with all these mistakes?
We had to get an.
Can you try the pip install with sudo? Yeah, just put sudo on the front of that. That will fix at least one of those errors.
Turning ask me for a password.
Yeah, it saves it for a little while. Kind of caches it. Or it doesn't save the password, but it gives you root access for a timeout. Yeah. Okay, so that worked. You should be able to run.
I should be able to run
Yeah,
with that.
you should be able to run it now.
I don't know what you did, but
So what did you do?
We just installed the development headers for ZMQ. It's this package libzmq-dev.
Oh, yeah.
And it was failing because it didn't have those headers. And ZMQ needed them. This is only a dependency of IPython, which is really annoying. So in the case that like someone actually totally can't get that running, and just say like just use the static version of the notebook and don't install IPython.
Oh, okay.
Yeah, I think that's the right fallback. Yeah.
I'm sorry for not being helpful.
No, I mean I can't be everywhere, so like I'm sure it's better than
Okay, so
people flailing by themselves.
Thank you very much.
Oh yeah, I hope it works now.
Well, let's start
And
following the
yeah, let us know.
whole thing.
So at 10:02, guys, we're gonna talk some more. There's like an official break at 3 o'clock.
So,
What's up, Walker?
well, so now I start playing around with the IDs because.
Yeah.
So I say, all right, well, I'm going to give everything an ID of 100 more than your number.
Okay.
And we see that it starts dropping them in.
Mm-hmm.
And we actually see, nice big numbers there. But
Yeah.
still, which suggests to me that
Mm-hmm.
the ID I create,
Yeah.
but Whoosh has its own ID.
I agree. Yep. So Whoosh definitely like has its own internal IDs, and it treats this. It's just a field called ID.
Okay, so it's just an alternate key that I could use
Yeah.
for search, but these are the real hardcore numbers for retrieving a document.
Yes. Though I think most of the time you're not going to end up using those. It's kind of an internal marker. Certainly when you're like updating documents, you're going to use the ID that you specified,
Okay.
not the Whoosh internal ID.
Yeah, but if I started with a list that was generated by a search from Whoosh, then those are Whoosh IDs. Not
Yeah, right. You're totally right in that they're different things.
Okay.
I agree.
Thanks.
Yeah, it's a little bit confusing.
That's cool.
All All right, sounds good. How you doing over here? Everything good?
Quite lost actually.
How can I help?
Well, I'm reading documentation. I'm not really sure where to start. To be honest with you, because well, let's see. I got two. I kind of understand what's going on, but not really. So I'm not really sure what Whoosh is really doing.
Here
Well, in general.
with the schema. Okay. When you say what Whoosh is really doing, you mean when it's creating the index?
No, when it's so. Well, this is the code, right?
Yeah, that's the code.
So this is the text, right? And then
Yeah. So this is our sample documents.
so this is magic, right?
Yeah. So this is just creating like a data structure that Whoosh uses.
And so, if I understand correctly, we define some fields that Whoosh knows about, and then it searches for things matching that description in the text. Comes back.
Yeah, so in this particular case, we're not doing any searching yet. We're just creating the index. So,
Well, okay, so it assigns an index to everything it finds. That matches.
So Whoosh is doing is processing these documents, and it's writing out this new data structure called an index.
Okay, which is then easier to search.
Right, exactly. So this is just the first step.
Okay.
It's not doing any searching, actually.
Okay. And then, so here in the fields, right, I'm trying to figure out what, so I'm guessing some of them are customizable, some of them are not.
Yeah.
I'm quite new to Python, by the way.
Sure.
That's not obvious.
No, it's fine. Yeah, so these are, there's a bunch of standard fields that Whoosh already knows how to deal with.
Okay.
So each of these particular fields, it just defines a bunch of rules for how Whoosh processes what's in that particular piece of data.
Okay.
So for like something that's specified as a text field, Whoosh breaks that up into individual words, and it's a little bit more complicated than that, but that's kind of the high level of what's going on. But say you have like a date, it wouldn't make sense to index that as words, because you're never going to search for that as words. So you have to have some different way of indexing that.
Right, so suppose I was going to add something like this to the schema, right?
Yeah.
So I'm not sure how I would actually put this into there, or if it actually goes there.
Yeah, so if you wanted to add another field, you would add another element to the schema. Yeah, like right there. So you got to give it a name.
Let's call it D.
Yeah.
And then, so I have to import it here.
Yep, that's exactly right. You got it.
And the same thing here.
Yeah. Pretty much just the same as all the other fields.
So now if I run this, it's going to look for dates inside all of this stuff.
Right. So one thing that you also kind of need to keep in mind here is that you also need to modify the sample, the documents, to also contain that field. And then when you're adding the documents to the index, you need to specify what the D field contains. So this is the loop right here where we go through this list and add them to the index. And if you just leave it as it is right now, it's going to create the documents, but not, all the date times will be blank. Because you don't tell it what to put there.
So, hold on. I didn't really understand what you just said.
I see.
So
So when you modify the schema, that's just telling it's telling Whoosh that you expect a different data format, or that you might have these extra fields. But you also have to modify the documents to contain those extra fields. Otherwise, they'll be blank.
That's okay.
Okay,
So,
I guess it doesn't really matter.
Okay, so it won't find any dates with the
Right,
documents.
yeah.
But if there were dates, so how does it actually know what format? Does it find the date in arbitrary format?
It takes Python datetime objects.
Okay.
Yeah, so Python has a part of the standard library that has a specific object that stores datetimes. And so when you pass something into there, it needs to be one of those objects. And then Whoosh knows how to deal with it. Does that make sense? And that's what the field expects is going to be different dependent on the field type. So if for other things, it might expect something different.
And breaks things by words. So
For text, yeah.
does it do anything else with text?
It does. So like one thing, there's a few different things that come up when you're dealing with a lot of text. One is that there are like a lot of words that are very common, but don't really help your search query a lot, like the or of. Yeah, so stop words. So it like strips out stop words. You can also modify it to make it so that like the bases of words match. So like if I search for email, it will also match the word like emailing. And that's like a way you can modify the schema. But it's all these things are just details, right? You know, it's always more complicated than just splitting it into words. Like, what's a word exactly? Do you count apostrophes? Right. Do you count white space? So how it tokenizes things is a little more complicated.
So
But you can basically assume that it's doing something reasonable. Why don't you like play around and see what happens when you enter different kinds of text? You can see what tokens it splits it up into. Like if you use are you using the IPython document? Okay, so you just click on this one. Yeah, so this is pretty simple. So can you scroll down a bit more? So this particular one, it prints all the contents of the index. So if you change the documents in this file, and then there's a cell. So each of these different individual cells can be run. If you click on that, yeah, it'll just rerun it. So you want to, if you scroll up a little bit, the place where, up more. Yeah, this one, where you run the index. If you modify this code over here to change the documents, and then you rerun the index generation, then you can see how it changes. So you can try like putting different things in here and seeing how it splits them.
What do you call them, tokens?
Okay, so I'm pretty much using token as a synonym for word. So when Whoosh processes the string, it does this thing that's called tokenizing. And that's splitting it up into words, basically.
Which aspect of this?
Ah, it's behind the scenes. You don't see it. It does it transparently because the particulars of what happens there is not really important. And it makes the interface much simpler. I think you can customize how it does do it. It's definitely like an advanced topic though. So
So there's a regex tokenizer that defines a word to be.
oh yeah, you know.
Backslash,
You've read the whole docs.
the
You
docs don't
you source
specify-
dived it.
Yeah,
Yeah.
the
All
docs
right.
actually don't specify what the default regex is.
Uh-huh.
The default regex is backslash w's
Okay.
followed by optional dot backslash w. So like anything that could be a legal internet domain
Oh, okay,
is
yeah.
a word to the regex.
Right. I
tokenizer.
did notice that when I put in python.org, it
Right.
strips off the
And that's
HTTP, but not.
It's missing from the docs is they don't
Yeah.
specify what the default pattern is. but
Yeah,
it's in the
right.
code.
The,
So it hits the regex.
the source code is very well. It's
So it
very
hits the
a joy to
tokenizer,
read.
which then goes
You're making question eyes at me. What's going on?
No, just listening.
Okay.
Shocking.
All right. Can you turn the mic back on? Okay, everybody. It's almost 3 o'clock, and 3 o'clock is the break. So I just want to bring everyone back together for just a minute here. All right. So I hope that everyone made some progress with playing around with indexing. Let's talk a little bit about it. Who managed to figure out what the weight is in a posting? Yeah, cool. So it turns out that one way to estimate how relevant a document is to a particular word is just to count the number of times that the word appears in that document. So the weight is pretty based on the frequency. And you can change the formulas for how Whoosh does weighting. In that if you have like different fields, if you're searching books, you might want to like weight the title more than the full text of the book. So that comes in later when you're trying to modify what are the most relevant results. Cool. Anyone get stemming working? Yeah. 1, 2. Over there. Hey, you in the back. What's your name? John, can you tell me what you had to do to get the stemming working? Okay. Cool. How did that change the output of your postings list? Ah, perhaps you should run it right now. And you can tell us. And for people that didn't get to stemming, John, can you kind of summarize what it does? Cool. Okay.
Before they send you, we have emails,
Mm.
mail.
Mhm.
Now you have only email.
Okay. So it maybe changes how that querying works, but not but actually simplifies the postings list. Cool. All right. Does anyone have any like questions that popped up from working on that? Do you want to ask right now? Silence. Um, I, I mean, you don't really lose information. It's just changing how the querying works, like what results will match. Oh, I see. Oh yeah, you could totally have different fields, one that stems and one that doesn't. Good question. Anyone else?
There's a multi-field query parser as well.
Mm-hmm. Cool. Well,
Same query field.
yeah. Stay tuned. We're gonna talk about querying after the break. As far as I know, the break involves coffee outside, but I don't know anything else about it. So I guess we can go investigate. I think 3 o'clock is right. That's what it said on the. Okay, is everyone back from the break? It looks like everyone's pretty much back in here. Cool. So no matter where you got to on the various kind of indexing exercises, we are going to talk a bit about querying right now, which is the second major half. So you create this data structure that you then use to find what you're looking for. So now that we played around a bit with creating the index, we're going to talk about querying, and I'm going to give you a bunch. There's a bunch more things that you can play around with for querying, and then if you guys get through that, there's a bunch of kind of advanced topics that you can jump into. So we'll talk about this, and then if you were still in the middle of something on the indexing stuff, you can feel free to like go back to that. We're going to have more open time where we'll be helping people one-on-one. And then at about 4:30, it's 3:20 right now. At 4:30, we're going to reconvene and kind of do a little summary. And there is a survey that the PyCon tutorial organizers want you to fill out. So I'm going to breathe down your necks and make sure that you fill out the survey so Stuart doesn't get mad at me. All right, let's talk about querying. So querying is the second big part of search. So let's go back to the handout. So for this section, now that we've taken a look at a very small example of documents for the purpose of being able to really look at what's contained in an index, we're going to move on to using a much bigger data set. So in the search materials, in this Git repo, I provided you guys with a subset of Project Gutenberg, which is a collection of public domain books that are all digitized and on the web. So I just took like the first 150 megs or something. I don't think it was that many. It was maybe like 50 megabytes of books from Project Gutenberg. They're all like a little bit obscure because it's too hard to like go through and find the popular ones. But there's a bunch of books that are in that repo, and I've given you all some code that will index those books. You should have already done these two things, which is extracting the metadata from the books. I pretty much just use some regular expressions on the books to get the title and the author and a few other things out. And then you should index them. That takes a couple minutes to run, so if you haven't done it already, you should do it right now. And I can pull up this code just real quick to show you guys. So this is our slightly more complicated index. And you can see that it has a more complicated schema. So we're still storing an ID, and we're actually storing the ID that Project Gutenberg gives us for the book. And then we're storing a title, which is just a text field, and the author, which is also just a text field. And then there's a couple other pieces of information. So there's a release date, there's a language. All the books that I've provided for you guys are English, just for simplicity. And then there's the full text of the books, which is the content field. And so this time we create a different index, but it's the same API, the same general process as in the simple index. So you can see that we're just previously we pre-processed the books to create this JSON file that has the metadata in them, including the full text. And then we're just loading the JSON file from the disk and using that to create our index. So it turns out that when you use a datetime field in Whoosh, you have to pass that Python datetime objects. So this one line right here about release date, is a little more complicated because we have to convert the Unix timestamp that we're storing in the JSON file into a datetime object. So that's the indexing for this new index, and we can see that it pretty much produces the same files as before. This index that I'm giving you is still pretty small, actually. I actually downloaded the full set of Project Gutenberg English ebooks, which is about 2 gigabytes. But I thought that was too much data to make you all download. So if you want a copy of them, I can give you a copy on a USB stick. But for now, you have like 50 megs, which is a lot more than your example before. All right. So in the handout, I give you an example of how to use the Whoosh querying API, and we'll run through it right now. So it's also very simple, just like the indexing. So we have this query parser object, which we have to pass the field that we want to search, and then the schema. And you can also search multiple fields, but that's a different API. And then you have to parse the query that you want to search for, and then you have to iterate through the results. Actually, yeah. So this example right here, I note that I was talking to, I think, Walker earlier, and we noted that you have to iterate through the results. So it was like, for R in results, print R. Oh no. Hang on. Ah, my code is broken. Where do we import opendir from again? Whoosh.index. I guess I never actually ran this example. Oh, yeah. Okay. Well, I'm just going to run it here for now, for simplicity. Okay, there we go. Yeah. Now like this. Bam. Cool. So we found 78 results, and I guess this prints out the top 10. Cool. Lots of great hits like the March Family Trilogy and the Book of Buried Treasure. Okay, so let's talk a little bit about parsing the query. So the default way that Whoosh parses the query is, so if you have multiple words that you're searching for, it combines them with the and Boolean operator. So that means that it's only going to be returning documents that have that word in all of them. You can change this. You can change it to be or. There is this page right here, which will give you the full details on the default query language. And it does a bunch of cool things by default. Things that I think are really cool is that you can, if you're doing a query, you can query for specific fields. So I can like do the title and the author, or I can specify just like the title by using a colon here and the field name. So one thing that I also provided for you all here is a little web app. So we're going to be using this to play around with this particular data set because it's a lot nicer to play around with searching the books with a non-command line UI. So I'm going to pull that up here. So I can search for like title, penny, and then can find a bunch of books. And then in this example code, if I click on the link, it will show you the full text. Just as Project Gutenberg gives it to you. So that's just like a really simple search interface that we have provided as a stub for you guys to build with. Yeah, I'm not sure how it works off the top of my head. I haven't tried it yet. Range. Oh, yeah. So it seems like it does like year, month, day, or something like that. Oh, interesting. But this is for a specific format. Yeah, I don't know how it deals with daytimes. You should figure it out and tell us. Duplicated. Oh, I see. It might be that I've like accidentally. Huh, that's interesting. I'm not sure. Either they're in the index twice, which is strange because they have the same ID, or there's something about this printing that is weird. Right. I might have messed something up at some point when playing around with all this code. I don't know, does it duplicate for you too? Yeah. Yeah, I don't know. Something weird with the data. I haven't fully debugged. But anyway, that's the basic querying API. Other notes, when it prints this list, it's sorting them by its definition of relevance. So if a document has a particular word more times, or if like you're searching for a field that's weighted more, that'll appear more towards the top. And there are API functions that allow you to see the weight. I haven't printed it here. But that's relevance. So depending on what kind of things you're searching, you might want to play around with that. Right. So I've given a bunch of other suggestions here for things that you want to do. So this is a pretty rich set of data to play around with. And this is a really simple interface for doing it, but you should be able to modify it pretty easily. So I can show you, whoops. If you ever used Flask, it's a really easy way to to create a little web app. So this really just, it's really just one page or 2 pages. And if you have questions about the web app, you can ask me. I think I'm like losing my voice a little bit here. Cool. So I'm gonna let you guys loose on this, and I'm gonna come around again. Your goals should be to like learn more about the Whoosh API. If you have a specific thing that you want to learn how to do with the API, work on trying to modify this little app to do it. And just explore. The point is to, you know, learn what you're interested in, and we are here to help you with that. Okay, interesting. Are I just indexing them wrong? I wonder why. Yeah, that's a bug. Can you you wanna fix it and send me a patch? Yeah, it's all it's GPL. got tired of being a cyborg.
I know. It's dangerous.
It's bothering me. The cookie one? Yeah, I can use that for the end. We'll swap it out. Slowly getting used to these things. Only have to use them a couple times before.
The bug is upstream of your code.
Oh yeah?
Yeah, corpus has duplicate documents.
Oh. Maybe it's in my spider.
Yeah, so like there's, say, 3334 and 3334-8.
Oh, interesting. Those are the same document. Huh. I wonder why it happened twice.
Sometimes it's done.
I wondered what the dashes were for, but I couldn't look into it too much.
Yeah, so like 3339 only appears in a single form, but lots of other documents appear in a duplicate form.
I wonder why that is. Strange.
You kind of have to continue wearing that.
Oh,
It's like
yeah.
it synced the video and the
Oh,
audio.
okay.
I'm sorry. I know.
I didn't know that if I wasn't using it, then it's still useful to have on.
Yeah.
Okay.
But I won't do it now.
Yeah, that's fine. I just didn't realize it was useful to you. Bam. Done. Did you get the installation stuff done?
Well, I hadn't done since yesterday.
Oh, I mean, working.
Yes.
Okay.
I had it work, as I told you, yesterday when you sent the email.
Oh,
I
okay.
made it,
Yeah.
and it was working. It's just that basically was trying to figure out what the problem don't worry,
Okay.
it's not difficult to use the API as far as I'm concerned. Basically, you have to define your schema and then figure out how to attach it to your list. Doesn't seem complicated.
Yeah, it's pretty simple.
Yeah.
Okay.
So I hope that I was so useful.
Oh yeah, don't worry about it. No, it's fine.
So the patch is just to delete all the -8s.
-8s, but the like -2s, or is it's only -8?
Well, oh, do you also have -2s?
I don't know. There might have only been -8s. Oh, interesting. Oh, I guess they're only. What about -0?
I don't know. I mean, really, you're just looking for that duplication. I mean,
Yeah.
So if you.
Oh, it's -0 and -8. Oh, interesting.
So
Yeah.
that's a really easy patch.
Yeah, cool. I feel like I want a bigger corpus now if I'm deleting a bunch of files.
It'll be nicer because it takes long enough already to index it.
Yeah. No. Yeah. It's just I'm telling Git to do it, and I didn't want to have to do that manually. But if you put the wildcard in, the shell parses it, so it doesn't pass it through to Git, so Git can't use the wildcard.
You quote it, give it to Git.
Yeah, I just backslashed it. Because I don't want to have to go through all of those and...
should I change the handout? Oh, I see. Oh. And then I gotta rerun my index. Oh yeah, no more dupes. Good work, team. Blinded myself.
So it strips out stop words
It worked.
So it looks like it strips out stop words automatically from titles and pieces. So if you look for a search for like
Yep.
the no results from.
Okay.
Yeah. Did you you didn't do that? It just did it automatically?
Correct.
You did indexing? Okay.
It's just the default
That's
behavior.
default. Yeah. Okay. Cool. So it should not. We shouldn't find any ands anywhere.
Yeah.
Okay. Cool.
Cool. There's probably a way to like make it not do that if you don't want it to do that.
Yeah.
Though.
I think they said somewhere in one of these ones. It's one of the one of the types of fields stored, not indexed, not searchable. There's one that stores it almost exactly, I think. But yeah, okay. So default is it does strip out stop words. Cool.
Yep.
Sweet.
You discovered it.
Hey.
Sweet.
Nice.
How you doing over here? You good?
The default. That doesn't matter if we put like a certain type on the default. We don't need to actually specify the field inside the parse command. And then if you put something else, then you have to specify it. Is that correct?
It's possible. I don't know if it's on my
Yeah,
just run it.
I'm not sure if I have everything loaded.
Oh yeah. Right. worst thing that can happen is you stack trace.
Yeah, just you won't find anything because I was just randomly picking words, but
Yeah. I guess you're not printing anything, so
no,
you don't
I
see
don't.
anything.
Just copy and paste at the top.
Uh-huh.
Somewhere else, I guess. Start finding something actually that
Oh,
makes sense.
yeah.
Panel extension.
Yeah. If you were like having trouble, you can always look through the books themselves to find something to search for.
There you go.
If you need inspiration, they're a bit obscure.
Oh, I just randomly pick words.
Yeah. I really wanted to like have like all of Shakespeare or something, but it was too complicated to spider the right books.
Oh, well, it seems to
So,
work though.
yeah, cool. Sounds like you're good to go. How's it going back here? Everything working all right?
Yeah, my Chrome just keeps crashing, so I'm trying to.
Oh no, that sounds like a pain.
Yeah, it must be.
Is IPython crashing it?
No, it's been doing that for like the last week since the last
Yeah.
Chrome update, and I have no idea why.
Yeah,
It says
it's
this
annoying.
last update fixed it, but it's still.
Yeah. When in doubt, try upgrading.
Yeah, I'm just going Firefox.
Yeah. It's nice that we have multiple browsers we can choose from these days.
Yeah, the only thing
It's
I'm
not
missing
working.
now is a place to plug in my laptop. My battery.
Oh, there's got to be power here somewhere.
It'll make it. It'll make it. It's just another
Yeah.
half hour.
Half hour, 40 minutes or something. Cool. Sounds good. Hello, how you doing? Did you get it to run? You just reading it? Uh-huh. Yeah. 75K, yeah. Uh-huh. Yeah, so different search libraries choose different strategies that end up having different trade-offs in terms of how big the index is end up being versus, say, how fast you can retrieve queries. Right. Yep. Yeah, that definitely affects how big the index ends up being. Right, and you don't want to store those. Yeah. Right. Yep. Absolutely. So the main reason that we were storing the content here basically was just to make it clear. I actually think that for I guess for the full text of the content, it is a bit silly to store it. For some reason I was thinking that if you want to apply highlights, you would need it, but you don't necessarily. You can use the original text because it stores the positions.
Yeah, the thing is, even store the positions, you still need the full content. When you look at the schema, for example, in every information.
Mm-hmm. Yeah. Right. Yep. Yep. Yeah, you're exactly right.
It seems like with the library, a lot of users can turn off the content to setting the content.
Yeah. Yep. It definitely gives you the knobs. Yeah. It probably shouldn't. Right. Oh yeah. Right. So you want to. There's only some fields that you're gonna want to store. Right. Yeah. You just want to be searching the metadata, not the document. Yeah. What are the binaries that you want to search?
The binaries have we all have the document structure, and we all structured like the document writing file stream into the files, so it's not visible to outside our structure. We just store this content of the file. For the library, not able to open to see the content.
Okay. Yeah.
In this case, the only thing you can search is the file structure or the keywords you have set up. Those are actually visible to the
Yeah. Cool. Yep. You're absolutely right. Agreed. What organizations are you working for? Well, Oh, I run my own company in San Francisco. Yeah. I'm not like officially involved in like Python. I'm a part of the Python community. What's that? We're writing email software. Yeah. In Python, actually. We have to do just a little bit of searching. Yeah, sure. It's Inbox. INBOX. Yeah, Inbox app. app.com. Yeah. Most of it. There's one piece that will involve embedded C code. And we might end up using like some Go somewhere at some point, but it's all Python right now. What is it? Okay.
okay. Oh, yeah.
On top of the underlying field.
Yeah, right. Right. Yeah. Yep. Cool. Well, we did it. Write down a couple things.
So for a boost, is that just bigger is better?
For boost.
For a field boost.
What is this? Wow, I don't know. What is a boost?
Well, it wants a number. I'll give it a number. Maybe it'll be
I don't
exactly the
know.
opposite of what I want it to do.
You can see how it affects the weightings.
Well, that's what I'm trying to do.
Yeah.
So here's some numbers.
Boosted.
Huh?
Yeah.
Well, I guess I should change those to floating point because it seems to want those.
Oh, if you leave the 0 off, it works.
Yeah.
Cool.
All right, we'll see what happens.
Yeah, I want to know. What does the boosts do?
Well, hopefully it lets me, so, let's see. I've got all these terms with women in them, although none of those have women in the title. I'm looking
Yeah.
for something where it's, okay, West.
I see. Yeah. Oh, okay. So put it at the top. Yankee from the West.
Let's see, is that going to show me?
Yeah, I think you have to print out the weight separately. If you're just printing out the fields, you won't get the weight.
Hold on.
It's a different API call.
Okay, where do we print? I guess I'd have to do my printing there. Okay, so except it actually showed me. So okay, where are you printing? Found. Ah.
Right. And then.
But it's not showing me a weight associated with that.
Right. So can you show me the code back again? Okay, so it prints the results. So the results that this is giving me back is giving me the fields. So maybe you can make that a tuple of like the weight and the fields or something like that.
Yeah.
So that's gonna break.
It's gonna break things.
Break
out.
a lot of things. Or you could print. You could just make a loop there and print, like do like 4R and search, or you could like assign this to a.
I'm gonna just capture
Yeah.
results.
Right.
List.
I just have to change the flow a little bit.
Well, yeah, I'm going back to my previous stuff, and I'm looking, like, if I do rank, well, that's boring, but if I do score...
Score! Okay, cool. Yeah, I'm curious. Let's see.
And see, I
Oh, yeah.
got a serious boost there.
Boosted.
Yeah. So now let's see if we can dial that up.
Maybe boost is just like a multiplier or something.
Crank. Okay.
Yeah.
Reload. Oh.
Yeah. Let's see what it... 268. Sweet. Boosted.
Es como si, bueno, justamente de hecho se parece mucho a una sinoidal de phone. Entonces ellos están desfasados porque... Yeah, porque...
When you want to know how the terms in some mathematical algorithm are going to start piling piles of 10 under the term you're testing.
Yeah. I hope you
Connecting
like
a high voltage to a randomly selected terminal in the circuit, and let's see where the smoke comes out.
Yeah.
Yeah, pero... Y yo estoy seguro, o sea, porque no sé, voy a revisando, o sea, como digo, yo era asistente de la matemática, pero era más determinista, no mucha probabilidad. La verdad es que yo le mucha nota, pero yo conozco un par de gente de la universidad, que tal vez no son programadores, pero que no yeah, pero, o sea, esto es interesantísimo. Vamos aquí.
And multi-field search, does that consider it to be like searching multiple fields at the same time?
I would expect so. This is something I remember Solar and Whoosh counting numbers. But we do support facets. It's like, and then how do I use it? Well, that means I could put like a date range on my query.
Right. Yeah.
And
it sounds like it could be a synonym. I think in the documentation they call it faceting. In the faceting documentation, they call it.
Yeah, so I this suggests that there's something that I'm not understanding about a facet, that there's more to facet than just searching multiple fields.
What does it say at the top? I'm curious.
I think this documentation assumes somebody who actually understands facet in general from a search context.
Yeah.
This is not a Whoosh question. So it's a Whoosh documentation limitation because maybe Whoosh is trying to advertise itself.
Right.
But if I just did search and facet, that might be more meaningful.
Yeah, right. Might tell us. Faceted search, sure. What does Wikipedia say?
Faceted classification system. So the very first thing is a term I've got to follow.
Yeah. Yeah, I mean, my understanding of facets is kind of like when you're searching on Newegg and you want to search for like computers in a price range. Those are like multiple filters on your data set.
So does there exist a
It does.
multi-field search that is not a faceted
Right.
search?
I don't know.
Or is faceting just a way for people drinking wine and eating cheese to, it's a shibboleth, like, you know what we're talking about.
Yeah, it might just be that. Good question. I guess a faceted search might imply and between the different fields.
Yeah,
And
so
if you have
as
a
opposed to a multi-field search where,
which it could be or.
yes, okay, so.
So maybe faceting is a subset of multi-field search. It's possible.
Pero sería un buen tema, de verdad.
I think it is kind of like a Newegg or a Yelp thing. I think what they're trying to describe is like an iterative refinement. You know, think like Yelp. You say restaurants, Chinese, open now. You know, price range in something. You keep adding filter terms to it.
Right. Yeah, that's certainly my understanding of what faceted search means. It does seem that's kind of a subset of this kind of generic multi-field search.
Para cambiar employees con.
How you doing up here? Playing around? What are you working on? What are you working on? Cool. As long as you're happy. How are you doing over here? Did you get it working? Good. Awesome. That's exciting. What are you working on right now?
Just trying to figure out how the query works.
Mm-hmm.
Figure out how to control how many results come.
Yeah. What have you discovered so far?
I'm just trying to understand kind of the syntax of putting the queries together.
Okay.
The idea that you can have optional Boolean combinations. One of the things that surprised me is I was trying to limit it to 20 results on the query, and I got back 23 matches, which surprised me.
Yeah, interesting.
Still still investigating.
Yeah, that's weird. Some oddity of the API. Yeah, misunderstanding.
Right.
Oh, the API is not perfect. In fact, I was talking to Matt, the guy who wrote it, and he was like, the next version is going to be so much better. Yeah. I think he was a little embarrassed about a couple of my examples that I had in the document. I was like, it's okay. You wrote this really useful thing. It doesn't have to be perfect. What's going on? Yeah.
This is how you search an exact phrase, right? So when I search this, and I pull up these documents and I look for that exact phrase that's not in there. So I'm just wondering if I'm doing
it might have something to do with line breaks. I'm wondering if the browser search doesn't deal with if like that phrase is broken up over a line. That's a possibility.
I see.
I would certainly expect that if you're doing an exact phrase search, It should appear.
Yeah. Well,
That's interesting, though.
yeah.
A mystery.
That's weird, yeah. Okay.
Yeah, you should investigate more, figure it out.
So here's that.
Yeah?
Here's that situation. I'm trying to basically do 20 here, and I get. I'm getting, and I wonder if this has to do with maybe the duplicated input documents or anything like that, or it just surprised me that. So I was going back through and looking at some of the Whoosh documentation. To try.
I don't know off the top of my head. From 23 matches?
Just try one.
Yeah. What does the documentation say for a limit?
It says that it normally does 10.
Oh, I see. So it seems to
Oh,
like.
it may be matching 23, and it's only outputting 1.
Yeah.
Yeah.
So it seems like it doesn't short circuit matching, but it does limit the amount of results that it gives you back.
Interesting.
Which is kind of funny. Because it still has to determine how many,
And the results are not they're not text, they're actually a list structure, right? So I'm counting.
Right.
So is this the right operation, length of results? To tell me how many?
Yeah,
Or,
well.
okay. Or am I just doing a list of a string? How many bytes, how many characters in a
Yeah,
string?
you might want to print results. I think it's some sort of. It's definitely a custom iterator, so I don't know how it defines the length field.
It's that object that was that contained a count of how many guys it matched.
Yeah.
It was not the actual count.
Right. So it probably has some custom definition on how it responds to the length operator or the length function. Yeah. Python, you can redefine anything.
Yeah, I'm probably printing something I don't expect to be printing.
It's possible.
That length operator, I think, is not doing anything.
It's a good mystery to investigate, though. Is your Python still working?
Yeah, but I'm letting me
Oh yeah, oh, that's kind of him. Cool. I don't know what's going on. You broke it.
Are you involved in the other searching workshop?
No. I don't know.
So the other search libraries other than Whoosh?
There certainly are. So Whoosh is the only kind of like production-ready search library for Python that I know of that is written entirely in Python. So all the other ones are Python interfaces to some other piece of software. And certainly Whoosh is good for like small to medium like sets of documents. Like if you want to make your documentation searchable on your website or like your website searchable. This is totally up to the job. If the data set gets really big or if you're like really optimizing for performance, then you probably want to use a different tool. I find like the documentation for most of these kind of like open source search libraries to be underwhelming. So yeah, it's pretty good. So I think it's really valuable to start with a library like Whoosh and learn it and learn the terminology, and then that knowledge just transfers to all these other tools. So even if you don't end up using Whoosh, it's still really useful. And yeah, if you're like doing something super extra strength, you probably want to use Elasticsearch, which is powered by Lucene, which is an Apache project. I think Lucene's actually written in Java, but it has all sorts of interfaces. It's kind of like the
most industrial strength open source search library out there. And then there's another one called Zapier with an X, which is written in C++, I think, and is also really good. And there's a few people that use Zapier, like, you know the company Fastmail? They're like a Gmail alternative, webmail. And they wrote their search implementation using Zapier. So, totally a very good search implementation. I have used Zapier before, and I'm not sure if it was like a bug in the Python bindings or something, but I was having this problem where, like, if I was like opening and closing the index a lot, it was like leaking file descriptors. So I got a little frustrated with that. But I don't know if it's like a bug in my code or like a bug in their bindings. But yeah, it's really fast though. Zapion's better, is good if you need like a faster solution, but you also want to have really tight integration into like your app that's running locally. Like Elasticsearch does this like clustering thing, and it's really complicated. But sometimes that's what you need. Like GitHub search is built on Elasticsearch. Yep, lots of people use it. Sweet. Yeah, I mean, it's totally adequate for a lot of situations. Yeah. Cool. I'm gonna drink some water. Mm-hmm. I don't drink coffee. It's clearly not a universal truth, given that I survived and still don't drink coffee and am not addicted to tea. I do like tea though. For some years at MIT, I didn't sleep a lot, but I found that my grades improved when I changed that. Yeah. Prioritize. You gotta prioritize it. Life is way better when you sleep enough.
Yeah, I know that feeling.
I've given up on sleepless nights.
So the burnout is, they tell that burnout is pretty common in MIT, right?
Burnout? Oh yeah. It took me like 2 years to recover from going there.
Really?
Yeah.
Oh gosh.
Feel fully human again.
Oh, nice. Whoa.
Nope. It's not your phone, it's someone else's.
Good. I was talking with your fellow.
Eben?
Yes. It's pretty interesting what you're trying to do with the email.
With inbox.
Yes,
Oh, cool.
I thought that I realized that it's pretty similar to what they did with requests.
Oh yeah.
It's like a request
Yeah.
for email.
Request for email, yeah.
And that's cool.
Yeah. Request is great. I love that library.
Yes, more. But I think that's the situation that I'm seeing more commonly in the standard library. A lot of stuff that is just there, and nobody wants to move or touch.
Mm-hmm.
So
Yeah, the thing with software development is that it turns out that backwards compatibility is really, really, really important. So you have to develop new things separately and make them compatible.
and that's the reason why we have the problem with Python 3.
Right, exactly. See, also, I'm still building new software with Python 2.
You have it? You have begun or not?
I'm still using Python 2 because of certain big projects that still aren't using Python 3 yet.
Yeah, I will make the leap
Yeah, I want to use it for like the tech stuff. Like,
but the libraries.
yeah.
Yeah.
What was
so,
the last blocker for you?
When I realized that I could get 3 running inside Anaconda.
Inside the Red Hat installer?
No.
No,
So,
Anaconda is a distribution.
yeah. So it's
For
it's,
big data, right?
Yeah.
Oh.
For just data. So there's.
I think it's
there
also
was
the Red Hat
Nthought,
installer.
an Nthought Python distribution, and then some people who worked for Nthought split off. They called themselves Xthoughts and formed Continuum Analytics, and they created a competing distribution called Anaconda. The Nthought Python distribution is now called Canopy. Now you've got 2 deluxe distros of Python that include IPython Notebook, so that's like what I was using for this class. Along with SciPy, NumPy, Matplotlib, Pandas, scikit-learn, all these goodies.
Yes. And they have something called like BOA or something like that. The analytics, like isn't.
Each distro of those 2 distros comes with something that is like its extra secret sauce.
Yeah.
And then they both come with a free version, which if all you care about is things like IPython Notebook, you're set with either one of them. Where Anaconda special is that it's
Continuum.
kind of weird kind of virtual environment replacement for using Conda, which is their tool, but it will let you create a virtual environment that contains a different Python interpreter. So you say, I want Python 3.
Yeah, you can do that with virtualenv too.
Yeah, it does, but it's actually what they do is they backport it. You even use a different name for it because it's the version of Python 3 that you're using. It's VM, I think.
Yeah, what I'm not talking about like virtual env support inside Python 3. I'm saying that I'm running Anaconda, some version which gives me Python 2.7, and then I run a command, and it's like I've got Python 2.7, but now I've got a Python 3 environment as well. And I can just activate it.
Okay.
Yeah.
So you can just run virtualenv and create an entirely different Python interpreter, because I've never seen that happen.
Well, basically,
You
in
have
web
to
faction you do that a lot. At least I think I have work, and that's pretty normal. I think. I don't know.
It depends on your base system with virtualenv. Like on Debian, I have like Python 3 and Python 2 installed, and I can run virtualenv with Python 3 and create a virtualenv with a Python 3 interpreter.
Yeah, so Python 3 interpreter creating a Python 3 virtual environment. I'm talking about a Python 2 interpreter.
Yeah, that's weird.
Python 3 virtual environment. Actually, downloading.
Yeah, that's magic.
And all the associated.
I was going to contribute to the discussion, but
I have seen that.
Oh, okay.
I don't know. I
Right,
didn't like
right,
implementation of the way I used it, but
Yeah, you have to like
seen that.
That's not just
have that
virtual
Python
env.
installed in your system.
But that was not virtual env.
Yeah, I didn't really know
Download
about
a
these.
Python distribution and 100 packages and
It's like special Python distributions.
But
Canopy.
that's pretty good. Anyway, but that's normally probably they do
Right.
better than the way I saw it.
Yep. Oh, I see. Is it for? Is it like for Windows and Mac? Something? Okay. Oh, okay.
And you can specify a different interpreter that already exists on your system when creating a virtual environment.
People use that
in
in
this case, I
like
was specifying an interpreter
scientific
that did not exist on my system, and it got created.
Yeah, there's a ton of compiled stuff, and it's
And not only did the
Okay, that
interpreter
makes a
get
lot of
created,
sense.
but all
Why
of
it's
the goody
default.
packages got added too. So it's not getting Python 3 up and running on your system is not special. Getting Python 3 and SciPy up and running along with IPython Notebook with 0 and Q and all that up and running on your system.
There's some work that's going on with having like pip support binary distributions as
You
well.
rely on your package manager, fine.
Wheels, yeah.
And that works as long as
Yeah, I've never
The
used
thing
it
is,
before.
that's not something you can tell a student with a Windows box.
I maintain my own wheelhouse. So many puns. But you can, like I maintain this locally on my machine, so I can do like pip install, and it automatically looks to the wheelhouse first to see if I can find it in there. and then goes and creates other things.
Mm,
So I can blow away a
uh-huh.
NumPy environment and recreate it in
Right.
like 2 seconds.
Uh-huh.
Yeah, just because it has to
Cool.
move and then zip.
Right.
Yeah, and I can do that without
Yeah.
the internet as well. Like on a plane,
Oh,
I can
cool.
recreate a new virtual env.
Yeah, I want to go to like, I think it's like Noah Kendrowitz, his like Python packaging talk.
Ah, yeah.
It's
No,
like-
wheels are like.
It's like it's so complicated.
Yeah. Oh yeah.
And I say this as a person who's like come from like a like a Linux distro background and like knows about packaging. I'm just like, God, I don't know what's the right thing to do.
Exactly.
Yeah.
Yeah. But yeah, no,
Cool.
like it makes it super fast. And even for testing, like if you need to create a virtual env right away and
Yeah,
run a test
right.
on it, just it's all just looks locally, it's all just disk.
Yeah. I should look into, like, the one annoying thing about the setup for like this tutorial was the PyZMQ dependency of IPython.
Well, you gave it
So-
you had it pegged at a very like you pinned it to like version 2 whatever. They recently because it's up at like version 14 or something like that right now, and PyZMQ
Yeah.
just as your version of 2.0 now ships a wheel, so you didn't have to compile.
Oh, interesting.
Yeah.
Oh, I don't know why I chose that version. Might have been a mistake or a typo or something.
Yeah.
Or like I was
pinned to a
looking
very
at the
specific
wrong
version,
thing.
right?
Yeah.
Yeah.
Oh, so they ship a wheel by
They
default
ship
through
a
pip?
wheel.
So does pip use the binary
It's
automatically?
It will. Okay, so let's see here.
Like if you just do like pip install PyZMQ, will it install a binary?
I'm not sure if it's a default now. I set
Oh,
my-
okay. So you have to configure it to
Yeah.
use
Well, this is I
wheels.
configured this a while ago. It may wheel
Yeah.
may become the default now.
Right.
But
Oh, okay.
yeah.
Cool.
And you can tell which ones have wheels.
Yeah, because like using pip is like the only way that you can make sure you're running the right stuff, but it takes so long when you have to compile everything.
Yeah.
It's like running Gen 2.
Yeah.
Anyway,
Yeah.
I'm gonna actually go back and start talking at the front. Oh, you have a question? One last question.
Search all fields by default. What option we found here? Multiple here. So is this, and we need to define a schema and then use the multiple parser, or what is the solution to that item?
Oh yeah, yeah. I think you should be able to use the.
But there is an option that use get all.
Oh, so I see.
Yeah, I saw something like that.
Yeah. When
here.
you use a query parser, yeah.
But I don't know if this is. Yeah,
Right,
he
so
was
you
saying.
have to have the query parser object. I think. Yeah, can you like pull up the documentation for this? If you click on query parser, is that a link? I want to see that. Yeah. Yeah, so I'm pretty sure you have to use the multi-field parser.
Okay.
Yeah.
So it's correct.
Because otherwise this will, it limits it to a specific
If
field.
you want to do that directly with the and the term, we have to specify each field.
Yeah, if you want a term to apply to multiple fields, you have to use multi-field.
Okay. But there is not a by default option that do it.
I don't think so.
Okay.
I think you're right. Cool.
Thank you.
All right, everybody. We are drawing to the end of our time here. So I wanted to grab everyone and do a couple things. One, kind of like run through the high level of what we just covered. Two, have you guys talk a little bit about the things that you just played around with and discovered. And three, get you guys to do this survey that Stuart and Ruben have been chasing everyone down to make sure you guys fill out. All right, so let's first run through kind of an overview of the things that we learned. So we talked a lot about basic search concepts today, and to review, we talked about documents. So documents are what you're trying to search. They could be book chapters or documentation pages or like elements from a database. And they can have different pieces of information associated with them. And you define the format of those pieces of information by defining a schema in Whoosh. And then there's the first part of searching, which is indexing. Could someone summarize for me what indexing is? Like what happens when you create an index? What are you creating?
Trying to build a map from the words to the documents.
Okay, and why do we have to make an index?
That's to search.
Okay, what's slow about not having an index? Okay, cool. That's a great summary. Good job. All right, and then we talked about querying, which is the process of taking some text that someone types in and translating it into kind of like a query that uses the schema and uses the index and pulls up the documents that we're looking for. Cool. So, right. Oh man, my voice is kind of dying. I've been doing a lot of talking. So let's make this. For the querying stuff, let's talk about some of the things that you guys discovered. So Walker, what did you discover about weighting?
About which?
Weighting?
Well, you can set up, if you set up a dictionary of like field names and some weights you want to apply to them, like say title, I give title weight of 40, author 16, and the rest say section 1, and I only did floating point. You can do this instead of the normal query parser, you can do this multi-field parser. You pump in your field names and that dictionary, and now a search where you specify like English, and if English appears in the title, it goes right to the top. If English appears in the name, be somewhere in the middle. If English was in the column at the content, then it would be further on down.
There's some kind of hierarchy.
Well, yeah, you decide what weights you want to give to your different fields. You communicate that to this multi-field parser that Whoosh has. And when you feed it an unspecified query, you just say, I'm looking for English, then it's going to look across all the field names that you specified. You have to give it like a list of field names that you're saying search these fields, and it's going to weight them based on that dictionary you provided and score the results appropriately. So whereas by default, normally things just score based on the occurrence within a document, now you're saying that some fields are worth more than other fields.
Cool. How did people manage to search for a specific title on a book? What did you have to type in? Yeah, there you go. And what if you wanted that title to contain multiple words? What did you have to do then? Cool. And what about wildcards? How did you search for a wildcard? Cool. And then if you want an exact phrase, how do you do that? Quotes. So Whoosh's default query language is pretty similar to what you might use on, say, Google. But you can customize it. And I don't know if anyone got to this part about modifying the query language, but you can actually change what different words mean in the parser, which is pretty sweet. All right, so I don't think we're going to get to talk about any of these advanced topics that people might have dove into, but if you want to keep working on this and keep playing around, you can jump into those advanced topics and use them to learn some more about different aspects of searching. And I want to close by kind of highlighting this further reading section on the handout. And specifically note that, so Whoosh is great for searching like small to medium-sized sets of documents. If you end up searching a lot of text, you're probably going to run into performance issues because it is a pure Python library. It's written entirely in Python, and Python's not that fast. So if you need to do something in an environment where you actually need really strong performance, you probably are going to use a different tool. But in terms of like the documentation for a lot of these tools is not very good, and so having a grasp of the right words, the information retrieval words that people use, and the basic concepts for how search works will help you end up using these tools as well. So there's one in particular that I wanted to point out. It's called Elasticsearch. This is what powers actually GitHub search. So people are using it in super high production environments, which might be a tool that you want to use if you're building something to search something really big. There's also another tool called Zapier, which is written in C++. And is pretty good for if you need to like deeply integrate a kind of like custom search solution into an application and are okay with having to compile some C++. There's a webmail application called Fastmail that actually does all their search using Zapier, so it's pretty industrial strength. All right, so now I'm going to try to convince you guys to do the survey. And I'm going to pull it up. Here's a link to the survey. And you don't get to leave the room until you've done the survey. And thanks for coming. That's all we got.